So we're going to look at factoring here. Now, factoring polynomials, it's almost like the opposite with it's almost like the opposite of polynomial multiplication. In that, when you multiply two polynomials, right, you're combining them in a way to make a polynomial of larger degree. That's what happens when you multiply polynomials. When you factor, though, you're taking a polynomial and breaking it into parts so that at least one of the parts is of smaller degree. At least one of them is of smaller degree. So now factoring, unfortunately, is a lot harder than multiplying. I mean, if I hand you any two polynomials, you know, it might be tedious, but odds are you'll be able to multiply and get the product. With factoring, however, well, that may not be the case. You know, with factoring, if I give you a polynomial, if the degree is large enough especially, it may be hard, if not impossible, to factor it. There are techniques we can use, though, for factoring. For instance, one is involving the greatest common monomial factor. Okay? So that's what we have here, the greatest common monomial factor. Essentially, the factoring technique is determining this and then factoring it out. We also have another technique, factor by grouping. Okay, that's another technique. We'll see it's a little involved, but it's not terrible. There's also factoring a trinomial. And again, a trinomial is a polynomial with only 3 terms. In fact, if the terms meet certain criterion, then that can determine what technique you use. So let's look at the greatest common monomial factor. With polynomials, we're mostly going to focus on integer coefficients. That's what we're going to mostly focus on. I mean, theoretically, you could look at polynomials where the coefficients are real numbers or even complex numbers or rational numbers. But let's focus on integer coefficients. All right. Okay, so the greatest common monomial factor, bx to the m, okay? By definition, it's also denoted by the GCF of a polynomial in x. This is the GCF, the greatest common monomial factor, if a few things have to happen. If b is the greatest common factor, okay, for each of the polynomial coefficients, including the constant term. The greatest common factor of the coefficients and the constant term. Okay. Also, m, the m here, this is the smallest exponent of x, the smallest exponent of x, found in every term of the polynomial. And if there's a non-zero constant term, we take m to be 0. Okay? We take m to be 0. In other words, we're using this imprecise convention here as a way to remember it. Really, though, if there's a non-zero constant term, you don't have a variable in the GCF. In other words, it's just a number. All right. That's what the GCF is, and really the factoring technique is once you find it, you factor it out. That's really the factoring technique here. But what do I mean by factoring it out? We're dividing by it. In other words, to factor this term out, you put it in front with parentheses, and to get what's left over, you divide. That's what we're doing. You divide. All right. It's just like when you factor a number, an integer that is, like 50, let's say. We know 5 is a factor of it. I mean, there are ways to see that. But how do you factor out 5, though, from it? Well, you put the 5 in front, right? And then you divide in order to see what's left over. That's just what you do. So it's the same idea there. Also, when we're dividing monomials, remember how when we multiplied, we followed certain rules? Same thing here. Namely, you divide the coefficients here. So obviously b cannot be 0 here, and you subtract exponents. Just exponent rules, okay? So we divide coefficients and we subtract exponents. Okay? All right. So we have that. Let's do an example. So let's find and factor out the GCF of this polynomial. Okay, well, notice the smallest exponent of x here is 2. Right? We have a 3x to the 4, 9x squared, 2 we have. So that's what we get here. Okay. So that's what we get here. Now, so we take m to be 2 then. 2 is the smallest exponent of x. Now, what about 3 and 9 to get b? Well, what are the factors of 3? Factors here can only be positive. I mean, some math courses, they will allow negative numbers to be factors. They will. But in this class, for the purposes of factoring here with the GCF, we're not going to do that. Factors can only be positive. Factors of an integer. So the factors of 3 are just 1 and 3. For 9, right, we have 1, we have 3, and we have 9. 1, 3, and 9. So what's the greatest common factor among these coefficients? Well, it's 3, as you can see. So b here is 3. That's what b is. And not only that, since m is 2, we have the GCF. It's just 3x squared. Okay? So it's 3x squared. So that's our GCF for this thing. Okay, so how do you factor it out? Well, it's just like I said before. You put it in front with parentheses, and then you divide to see what's left over. We divide. Okay, so for instance, if you have 3x to the 4 over 3x squared, right? Excuse me, sorry, I skipped a step. We have 3x to the 4 plus 9x squared. We divide by 3x squared here, and that's the same thing as dividing into each term, like so. Like so. Okay, well, when you divide, remember, just like we saw before, you divide coefficients. So here the 3's are going to cancel. X to the 4th over x squared. Well, that's just x squared, right? You subtract the exponents. And here, 9 over 3 is 3. X squared over x squared, you know, they cancel. So this is what we get here. You could check it like I'm doing, right? We multiply, okay, like so, and we get this. This is what we get. We check. So this is what happens. All right, that's good. Now, before I move on, are there any questions about this?
Do we have to use that formula?
What formula?
The like showing that you're dividing over 3x squared. Like that.
You mean show all this work?
Yeah.
Not every step, but you should show enough so that I know that you know what you're doing. Does that make sense?
Yeah.
I'm sorry?
Yeah.
Okay, good. I didn't hear you. Sorry. Okay, my neighbors are vacuuming, so. All right. Good question, though. Any other questions? Okay. So that's this example. Now, there is something I want to illustrate, and we're going to illustrate. Well, let's try and find the GCF of x squared plus 3. What's left over? Let's find that. Basically, the GCF is going to be 1, and let's just verify that. Although it's not too hard to see. I mean, for 1, notice there's a non-zero constant term here, right? So the m, the smallest exponent of x, has to be 0. Okay? It has to be 0.